Assalamualaikum. Today we are going to discuss about plasma physics and controlled fusion by Francis F. Chen, second edition, volume 1, plasma physics. And my topic is Bohm diffusion and neoclassical diffusion. In classical physics, we already in classical diffusion we already discussed about it in detail. We got formula of diffusion, which one is m perpendicular with t sum of kt over b square. It was the diffusion which was used for above 1960. You can say above 19s. From classical, you all know very well the classical means the work done before 19s. Then, after 1960, Bohr and his two friends, Massey and Europe, use this machine which gives us a diffusion for the magnetic arc of uranium isotopes separation. What they observed that the given value of diffusion is much different from the value of absolute diffusion. You can say the value of absolute diffusion is much greater than the value given by classical diffusion. For this purpose, Bohm gives us a formula of diffusion which is 1 over 16 kT over AB, which is also known as Bohm's diffusion. It shows that Bohm diffusion depends upon temperature but independent of magnetic field, and you can see there is no use of density in the above equation of Bohm diffusion as classical diffusion. Then for the constant temperature, we consider a cylinder whose length is L, radius is R, and area is 2 pi r square, whereas volume of the square is pi r square L. The time constant formula is total number of particles in cylinder divided by partial n over partial t, which means change in particle with respect to time. For this we can write it as n pi r square L over S total number of particles. In these total number of particles means that it is consist of ion electron pairs or ion electron particles, and with respect to change can be written as flux 2 pi r L. You can see some values are cutting here, so we can also write it as 2 flux. This flux is also known as Fick's law, and according to Fick's law, flux is equals to diffusion n over r, or you can write it as minus and bipolar diffusion partial n, and we can write it also like this for our Bohm diffusion. Now my above equation for time constant becomes n r over 2 Bohm diffusion n over r, and by cutting and adding we get r square over 2d by, which is also known as Bohr's time. Bohr's time. Bohr's time is defined as the time taken by particle to diffuse from one region to an other region by Bohm diffusion. This is called Bohm time. The time taken by particle to diffuse from one region to another region by Bohm diffusion. By using this, if we apply equation of continuity, we get partial n over partial t plus delta dot negative Bohm diffusion delta n equals to 0. By putting this value on right side, we get this negative vanishes and it becomes positive. As we already know, the value of Bohm diffusion is I'm going to discuss you about the value of Bohm diffusion, as we already discussed about Bohm diffusion. Maybe I mix some things. After Bohm time, we can check the absolute value of diffusion which gives idea to Bohm to work on the value of diffusion. For this purpose, we can write that we have 100 electron volt at 1 Tesla. So the Bohm diffusion formula is 1 over 16 k T over E B can be written as 1 over 16 1.6 into 10 to the power minus 9 1 1.6 into 10 to the power minus 9 10 square, and we get the value which is 6.25 meters square per second. By putting same these value on classical diffusion, we get 2 3.33 into 10 to the power minus 4 meters square per second. So you can see this minus 4 10 to the power minus 4 is disagreement. I hope you can understand what and why we use and study about Bohm diffusion. Thank you.